Hello Internet, welcome back to Daily Codes. Today we are going to work on the API. Previously on Friday, the video about scraping HTML data, I showed you how we wrote scrape fuel, and we were able to fetch the data from the temporary folder and scrape it and see the data when we try to post to API. We also wrote this post to API code. It's in libraries. Where's my libraries? Yeah, post to API, and we had not yet built the API, so we just wanted to see the way the data will look like whenever it is posted. So this video purposefully is to create the post to the API. I mean, that will help. That will be receiving the post from from our code or Airflow whenever Airflow runs. So we're going to create this. Also, I left you with the task that you should be able to write code that will help you to scrape weather data. That code, I have it here. It still takes the same format as the scrape fuel, but there are different tags that we use. Remember, in scrape fuel we used an ID, div tag, and table header, and some way of manipulating those tags to be able to get the data that we want from those files. In scrape weather we also do the same, but we're using div tags and classes. This code is in the description in case you want to see how I did the scrape weather part. And if you have any question about scraping the weather data, you can leave it in the description. I usually respond to all comments in my description. So today it's not about scraping, it's about creating an API. And what I advocate usually is to have readable code, and one of the good characters of a readable code is to have not so many lines on the files that you have for your project. And what helps in making sure that you don't have so many lines is to have each class being in its own file. So like scrape weather is in its own file called scrape weather. Post to API, it's in its own file. And it's the same thing I'm going to do with the building of API. The framework that we are going to use when we are building the API is fastapi, and also we're going to use SQL Alchemy for object relation mapping, plus the database behind the API is going to be postgresql database, or Postgres database in short. So let's create the files that will help us build the models and the schema and so forth. So the first file is going to be models.py. Then the second file is going to be schema.py. So models.py will contain the tables, and the tables are defined as classes. This is the only file where you'll have more than one class in the file, but this file does one thing, which is creating tables, and these tables will be like one-to-one mapping between the classes in models.py is a one-to-one mapping with the tables in the database. So I'm going to create this, then I'm going to create schema.py. Then I'm also going to have database.py. This video is going to be long, I think. Sorry for that, but at least we're going to learn a lot from it, hopefully. Hopefully you'll learn something new from this project. Then there is crowd.py that helps in creating, reading, updating, and deletion of stuff from our database. So each of this is doing a specific task. Okay, so let's begin with models.py, and I'm going, before I begin with that, let me define database. So with the database, I'm going to use SQL Alchemy. So I'm going to say from SQL Alchemy, SQL Alchemy, we're going to import create engine. So create engine will help us to create engine. Whenever we want to query the database using a session, we need to bind an engine in the session maker to be able to create a session of communication with the database. Then we are going to have declarative base. So from SQL Alchemy, this is the second time I'm doing this in this channel. I also have a video for creating an API using fastapi, creating endpoints. So you can also check it out and also subscribe to the channel because we do this. And I don't shy from doing this because I know we learn from repetition. You can't just see something once and then learn from it, more so when you're coding. So if we do this several times, then it becomes muscle memory. So ORM, we are going to import session maker. So the session maker helps us to create an object that will be creating sessions with the engine bound to it. So import session maker. Then we are going to have our URL the same as the one we had in fastapi. The same as the one we had when we were creating Apache Airflow and when we were configuring it. If you have not checked that video, you should also check it. It's part of this video series. And when I say this video series, I mean it is a playlist on this channel. So you should just follow the whole project and see what we have been building up to now. And I hope that this is going to be the last video so that I don't bore you with a lot of stuff. And we jump into another project that will be fun. So let's say database URL, or we call it SQL. Whenever you're defining global variable, we should have uppercase. Why is my uppercase not working? Yeah. So SQL Alchemy database URL, and this is going to be a string. I'm going to copy this string from this side. I am copying it from the project that I worked on. So this project, I'm not working on it now. I worked on it before. So I'm just having one screen this side with the project code, then I'm just coding with you so that you see my thought process. So this URL, first of all, the way I define this with all uppercase is because it is a global variable for everything else that is in this file. And that means that, okay, this is PEP8 style guide. If you PEP8, yes, style guide. If you read it so that you can follow it, and it's also readable when someone knows that this is how the global variable will look like. So let's create an engine. Engine is going to be create engine. Remember we imported create engine, and this engine we are going to use this variable, and I want whenever I'm creating this engine it should show stuff on terminal. If I need to debug it, we'll look at it. So echo equals to true. When we look at this, we are saying that we are creating the database URL is Postgres, and the user is fastapi user, and the password is also fastapi password. Fastapi user as the password. So username, password, and then the host, and the database is script data. So let's first confirm that this is right. So I'm going to launch pgadmin to look at the database. I don't remember what we defined as the database. I can look at Airflow config and look at the SQL Alchemy connection. What's the master password? Okay. See the database we created. So when I was looking at this, we had Airflow YouTube user. So this is for Airflow user, and the database is called web data YouTube. So let me correct this in my database here. Then we're going to create this user as fastapi user into the database. So this is the database. Let me maximize this. The database is called web data YouTube. We are not going to put our data in this public schema because the public schema in this project contains metadata for fastapi. So let's create another schema so that we are organized also on our database. And our new schema, we are going to call it, let's just call it data or API data, API underscore data, save. Then we are going to create a user. So I need to open the query tool. This is so big. How can I reduce the size of this? Can I collapse it? Okay, I don't know what's happening with this. Let me close it. Yes, I'm going to leave. Open it again. Okay, let me confirm that this is clear on your end. It's not, but let's go to query tool, and then I make it bigger for you. Nice. So we need to create a user who is who will access the database, and that user will be the fastapi user. So we're going to write here, create user, fastapi user, create user, fastapi user with password, the password should be the same as the username for now, but for security purpose, don't do this on production. First API user with a password that, then we're going to grant all privileges to this database, the same way we did for Airflow user. So grant should be grant all privileges, I think. When you clicked on this video, you thought that I am a master. Then I say, I think. I want it to be in uppercase. So grant all privileges. This is what disturbed me when in the Airflow vid. I hope this time around I typed it correctly. On database, and the database is this database, web data YouTube. I'm going to copy it from here. So we are granting all privileges on that to this user. For now, but as you are pushing this to production, you'll need to know which privileges the first API user will have, so that if in case you have a security problem and someone figured out the username and password for your database, and maybe the host of your database is not protected by firewalls, then the only resources they will access will be the resources that are exposed to that user. So for Airflow user, you'll have to figure out privileges that you'll grant to that user. And also for Fast API user, you'll figure out that, plus the rest of the users. But for now, let's make it easy for all of us since we are learning. Run this, the user is created, then the privileges, run that, and it's done. So we are going to get this, and we say first API user, we change it that way. So we have SQL Alchemy, that. So that is the engine. And where are we? Database, this side. Okay. Then after creating the engine, we are going to define an object for session maker, and we shall call it session local 1. Because I am very talented and I know lots of I am so original. I mean, I didn't copy this from Fast API documentation. That name is original for me. Session local 1 is a very original name. So session maker, we don't want it to auto commit. So auto commit equals to false. I also didn't copy this from the documentation of Fast API. Then auto flash is also false. We don't want it to remove stuff when we don't tell it, and it should bind it to the engine we have created up there. Noise. Then let's create our base class. I don't know why I'm putting it here, but let me just put it here. Also, I didn't copy from the documentation. That means that you should read the documentation. That's what I'm trying to mean. So declarative base, and we instantiate the base class. So this base class is the one that will help us in building the models. I mean, not machine learning models, the database models. the ones that define the classes, I mean the ones that define the tables in the database. So now that we have this, we can now go to models.py, and we are going to import this base. I don't know why we didn't define it here, but I saw it in the documentation, so copy things and paste them. So let's define our tables. So the first thing we're going to do is to import from the database import base. So we're just importing this thing that we created it here. I don't know why I could just not create it here, but I'm copying. So base, and this base is the base class, the same as these other classes we were creating here as base classes if you've been following this project. And we are going to inherit properties from it, characteristics, methods, everything, because it has the DNA, original DNA for the tables. So it is, in fact, this class is the one that creates the tables. All tables have characteristics from this. We just add more properties. So we are going to create the first table, and the first table is going to be called fuel. Plus, remember I said that we are going to have our data here in the schema here. Please, we are not defining it in database here whenever we are creating an engine. There is a documentation that shows you that you can define it here, but for the purpose of creating models, I don't use Android. Please don't unsub because I'm using Android. I don't. It's not mine. So the base class, well, that's where we are, and the schema. I'm not putting the schema here whenever I'm defining the session, because in the API, I mean the endpoints could be pointing to several schemas here, and if I bind it here, I will restrict this code that I've taken years to write, not copying from the documentation, to only one schema. So I rather define each table, and in that table I define the schema where that table will be created. Hopefully you've understood. So base, we inherit all those DNAs. Then the table name is going to be, that's one underscore, it is double underscore, it's one, so it should be double underscore table name. Let's call it fuel, not fuel. And then I'm going to speed up this. What you need to know also is maybe this and the stuff that we're going to import, and these ones will be used to define the columns in the table and the data type of the columns. So I'm going to maybe do two, then the rest you I think you will just understand when you type them. So SQL Alchemy import. So this one I'm importing data types. So there is integer. There will be a data type called integer. Column is not a data type, but it is a feature that helps us to define the variable and telling the variable that this is a column of the table. You'll see how we use it. String is a data type. Float is also a data type, and I have a data type datetime, which I don't know if I'll use. this datetime, the second one. Also, I'm going to import datetime. Yeah, and remember that from this project, I told you that whenever you're importing your own libraries, separate them from the libraries that are imported from pip, so that when someone is reading your code, it's very important to be careful with the code and thinking about someone else who will be reading the code, because we spend a lot of time reading code than writing code, because we want things to work right and debugging them and solving issues. So you don't want someone to have a hard time reading your code. Even though you're most advanced programmer, you always go back to, will it be readable? So let me pause the video here, then I create the table, then explain. Yeah, I have created the features of the table, and I totally didn't copy it from somewhere and pasted it here in seconds. So the column here is the column is a class that defines the column, and it tells the code, or it tells us or everyone plus the code that plus the system that ID is a column of a data type integer, and it is a primary key. The same USD price per liter is a column of a data type float. What else? Created at is a column of a data type the time. The default data type is now, and it is not nullable. Default means that when you post data to this API endpoint and you've not provided created at or updated at, then the default value that will be put in the table will be that date time. Then this is what I was saying. The argument here, schema, should be data. Let's confirm. Schema here is API data, not data. So let's update this to API underscore data. So let me pause and create the rest of the tables. Again, I totally didn't copy from the project that I worked on, but we have another table here called weather. I'm going to give it 2 spaces, separate it. It has these columns ID, temperature, temperature unit, still column class that we imported here is used to define the column. Then it's a float. What else is not new to us? I think all of them. Yeah, we have here this. So this country is a column of a data type string, but the number of characters is limited to 2. For country, I think this is the only thing that is new in this case. And voila, so this is how we define the tables. So I have 3 tables defined here. So the next thing we are going to do is creating the schemas. So let me go to schema.py, and we are going to create the schema. So the schemas are the is the way the data is represented whenever it is posted or read. Please don't mock me. Or read from the API. So let's define the schema. We are going to use base model from Pydantic, and we're also going to use datetime and optional. Typing is very important for when you're defining the schema, because typing helps us define the data types So whenever data is posted to the API endpoints, the schema also checks the data type. So let's use from Pydantic. We're going to import base model. Then from datetime, import, I don't know why this is not looking right, but let's continue. Maybe we didn't install them, but it's fine. Import date time, then from typing import optional. Something is wrong somewhere, and I am not sure. I'm using the virtual environment. Anyway, so let me get this code from this side, because the video is going to be too long if I'm going to type everything. It's better I explain them than typing. So we have the fuel schema, fuel base schema. So the way I've created this is to create a base class first. Then from the base class inherits from the Pydantic base model. Then I define the features or the columns that I expect, or the something that will come with the objects, the keys that will come with the JSON objects. That so for fuel base, or for the base class that I'm creating here, whatever you see here, all these columns will be shown, whether you're posting data to the endpoint or whether you're getting data from the endpoint. You will expect this. But when we come to create, we will expect you to also add the country. So you see, fuel create is inheriting from fuel base, this base class. So this fuel create will have all this property plus this. Then that is when you're creating fuel. But when you're getting, you will have also the ID, which is automatically created. You'll have the country, and you'll have the date updated and created. Also, we need to define we need to tell we need to tell Pydantic that this is an object relation mapping, so that yeah, if you don't do this, then there are some errors. I don't remember which error I was getting, but there was some weird errors with my JSON file. So we need to make sure that we tell Pydantic that this is object relation mode. So it's the same thing for this. Remember, we also define the typing here. So this type, there is a difference between the way you define the schema types and the models types. So the type here is an integer, and you are seeing that this is an equal sign. But when we are defining the schema, it is like key value pairs. You need to take note of that. So we created for fuel, for weather, and for exchange rate. So now that we have the schema defined, we are going to work on the CRUD. So with the CRUD, we are going to write functions or classes that will help us to create, read, update, and delete stuff from the database. And there is a lot that I wrote, and if I start writing it, since I'm a very lazy programmer. I think all programmers are not lazy apart from me. We shall take hours writing this video, so it's better I explain. So we have session, we are importing it from ORM. This will be helping us to define the typing for the variables that we are getting. It is different from the session maker that we have here. I repeat, this one here will help us when we're defining the variables, the arguments to our function, and this is just to help us in typing. Right, now that you've understood that, we have a HTTP exception in case someone is calling an endpoint and there is an error that we want to show to the person, then we're going to use that. We are going to import our, so I want to separate this. Datetime also will help us in creating this. You'll see it. Then we have schemas and models are the packages that we've just created here and here. So let's begin. So we have the first function, which is to get, that is the R bit of CRUD. So this create, read, update, delete. So R is read. So this function helps us to read the database, and it's going to use the DB argument, which will be the variable, to query models. So we're going to query the fuel table. So remember models, we've just imported models here, .fuel. So that is what we are querying. And we are going to filter by saying that we want the first ID because we want to get a particular fuel ID and we get first, just in case there's a problem where this is repeated, we get the first value. The same as getting fuels, but this is a plural, this is getting everything. So you'll see that we're not getting first, and we are also not filtering the way filtered here. So here we have db.query models.fuel. So we're also querying the same model, the same table in other case. And we are skipping some values in case someone say, let's skip the first 100. This helps in pagination. If you've been doing some front end, you'll know pagination. Then the number of values that you have to return, or the number of objects you have to return, and then get all, because we want all. So this is fuel get. So we can create also fuel, like if you want to post data that you want it to be saved, and mostly we are going to use this. So we have, it takes this for the type, and then the fuel is here. Then we create an object from that fuel by making it a dictionary because it was JSON. Then we create an object from it, then we add that object to the database, and we commit, then we refresh the database and return the item that we have saved. So the saving happens here. Then if you want to delete, takes the same process as the one of get, but in a different way. We first get the ID that you sent, then you query for that object. Then when you get that object, if it doesn't exist, we return an exception, and the detail of exception is value not found. But sorry, if the value is there, then we delete it. There is a function also in this argument that we're going to be passing here that will help us to delete. Then we commit, so the deletion happens here. The link to this code is in the description if you want to see the whole project or just this file. Then we return this, we say delete, it's true, and the item that was deleted is that. Then update, in case you want to change some value, we do the same as get that value from the DB, then change what you want to change, any of them. Then after that, we do a commit. When you do a commit, it will just update the fuel to update. So the same happens. So this is for fuel, the whole of this. Then this is for weather, and this is for exchange, securities exchange or exchange rate. Yeah, so this is how we create the read, update, and delete file. And now let's look at our main.py. Did I create it? No. New file. Then we say main.py. And in our main file will contain the endpoints. There is a way you can use fastapi to route the endpoints, but I just thought that I could put them here. It's pretty not readable. I'm not proud of it. But this project has to be done, and then we start a new one because now it's becoming pretty much boring, and it is a long project when it comes to recording videos, and some of you don't want to watch up to the end. So yeah, so let's look at this. Also, I'm going fast because there is also another video in the channel that is showing you how to create the endpoints and fastapi API stuff. The link to the video is also in the description. If you want to learn a lot from it, you can also watch it. Let me explain this. So main.py, the first thing is to define fastapi object as an app. And in this app, we have the title. You'll see where this happens in the UI, the description, and the version. Then we have our model. So let's, you see, I imported the CRUD that we've just seen, models and schemas. Also, the session maker and the engine are imported from the database. So everything is just imported, which is in this API folder. Then we are going to look at this. So this is the way we define the endpoints using the decorator app.get. So if someone wants to get data, that you'll use app.get. This app here is already defined here. So this decorator app.get, whenever someone uses get for fuels, it comes here, and the response will be a list. The tag, you'll see where the tag comes in. Then whenever they are calling, they have to give us the limit. And then also how much should they skip. If they don't provide us, we put 0 and we return 100. And the session, it depends on getDB. GetDB is a function that we created here that instantiate the session maker that we already bound to the engine here. So we go back to main. If the session maker cannot be created, then we return these exceptions. Yeah, so so whenever this is successful, we get fuels and then we return fuels. When someone calls get fuels, we'll get the first 100 if they don't provide any other stuff. This is also get fuel and then a particular ID. This will get for the person only that fuel, if that fuel exists. Like if it doesn't exist, it's going to return fuel values not found. But if it exists, then it will not return it will return this if it exists. So it goes to crude get fuel. Remember, crude created here, get fuel is here, then it runs this, whatever it returns is an object which will be returned here, and that is what will go back as the response. So we have these functions. There are so many, but they do majorly the same thing. Get, post, put, delete is the same as delete, and put is update. Yeah, so let's run this. Hopefully we have not taken more than an hour. Let's run this. There is something I need to see here. Yeah, I think we are okay. Yeah, here. Models.base.metadata.create all bind engine. So this one helps us to with migrations. I don't know how I can explain migration. So it will help us to automatically create all those models that we have defined, because we have not gone into the DB and say, okay, in API data, in tables, let's create that table with the name and the data types and what. We have done it inside here in models. So what we're going to do is to have this that tells the engine, please create all those tables if they don't exist, or update them if they exist. And we are good to go. We have given it password, we have given it the username, we have given the link to the database, we've given the schema in the tables. Remember, in the models here, we say that the schema is here. So it is now our employee. We just tell it, create all, and it goes there and it creates it. So what do we need to do? We need to go to the terminal. I'm going to activate the environment, then I make it bigger. Let me make it bigger first for you so that you can see, because I care about you and what you learn. You have to be very comfortable looking at what is on the screen, and because I care about you, care about me too, and subscribe. Hey, by the way, how many subscribers do we have now? I'm going to pause this so that you don't see what I watch. Oh, we have 125 subscribers. That's good. I never expected it. Please subscribe to the channel. It's a good motivation for me to know that I am teaching people something that I know, and also just for motivation purposes. And I care about the 125 people, and my purpose is to make sure that you learn as much from me as possible about data engineering and data science. So subscribe and be part of they call it what, when you have a group with a purpose, it's called movement. Yeah, be part of the data movement and watch a bunch of videos. Okay, let's continue. That's too much digression for now. Yeah, so here is where we were, and we are going to, yeah, we wanted to launch that API, so I'm going to activate the environment. If you didn't watch how we created this environment, first clear so that you can see this. There is a video when I was setting up the project. In this video series, you can look at it and see how we set up the whole project plus the installation of the environment. So the end bin activate. Yeah, so we have activated this. If you do a pip freeze, you'll see the fast API installed somewhere. Yeah, we have this fast API. We also have UV icon. Hopefully. So let's try to run that fast API. So UV icon, then fast API using API dot main, and we want to run up. Hopefully it runs. Unknown location API. Oh, let's export Python path. Should be here. Then let's run this. Reload. That's how we write reload. Let's just run it. Cannot import name schema from API. Is it schemas or schema? Did I call it schema? It should be schemas. Rename schemas. What's going on? Why is it renaming even for participants? Schemas is here. I didn't tell you to rename for participants. Let's run it again. Background error. Yeah, you see, so I can see create table API data dot fuel. If we didn't do where is here database, if you didn't do echo equals to true, we could not be able to see this traceback. So here it is saying that create tables icon. This permission denied for schema API data, table API data dot fuel. Why is permission denied? I think we have fast API user, fast API user. Let me try to use the original fast API user and we see. And the schema is API underscore data. The database is web underscore data YouTube. So let's try to run this. Create table data dot weather. Oh, okay. So I think there is a problem here with our models. So this is API underscore data, but there is this. It should be that, and this should be that. Let me run it again. Voila. So the problem was that I was referring to a schema that does not exist. So let's run this. I'm going to copy this and I paste it in the browser. So the browser here, run this. Then I'm going to /docs, docs, and we have our API here, documentation, excuse me, and the endpoints are here. So this is the first endpoint. We can query it, but it has nothing now. We don't have data, and the weather and the exchange rate. So we have all these endpoints, and it's created by just a minute, and it's created by the code that we have written today. So we have, so how does it work? Because it's all over the place. Let me organize it for you. So we have main.py. Main.py contains the endpoints, these endpoints. So whenever you call this, the first file that will be hit will be main.py. And the main.py will help you to route. Fastapi has a way of routing, a better way of routing this so that you don't have all these lines of code. But since it's me and I'm lazy, I put all of them in one file. I'm sorry for that, for people who will be reading this code. Also, the code is in the description, and don't forget to subscribe. So we have this. So it comes here. When you try to get data, let's try the one of posting, or when you try to post data, it comes here. And your data is taken as this fuel variable, and this is the data type. We use typing. The DB, it depends on get DB session, and the DB is just a session maker, local session one, which we created here. The session maker bound to the engine. Then when we do that, we know that now DB is just creating a session that connects to the DB that we want, and we have this. It goes to CRUD. Where's CRUD? CRUD is here. CRUD helps us with create, write, create, read, and update and delete functions. We have them here. They could be classes. So also, I'm not proud of this because there are several things in one file, but could be organized better. So we want to get fuel. We use the session, and in that session there is a query. And what are we querying? That table model. Remember, in models we define the table, and what do we want to do with the query? This models is here, the file that defines the table, and we are done. So there is a schema. The schema is the one that helps us do this. Let me show you. Helps us to do this. When you are getting the data, this is for get, and also when you post, it gives you the format. Please post something like this. Yep. So that is what the schema helps you with, and that is how we create the API. And that is majorly the end of this video and the end of this video series. You can try to run Airflow. Before we do that, let me run it for you. Let me just do the whole running, and you see if data goes there. There was this. So we already have fastapi running, which is okay. So let me close this. And then there was post to API. Now let's uncomment this. Then let's run Airflow and see if the data will go to the database, and we try to query. Then if that is possible, we are going to end the project here. The project contains, if you go to GitHub, you'll see it contains files to do with Dash. I'm not so proud about the work I did on Dash. I want to show you the best of the best in the projects. So I'm not proud of the work I did on Dash, so I'll not have a video for it. But if you want to see how I connected Dash to the database and then built a simple dashboard. You can just go to the GitHub repository and then look at that piece of code. But hopefully in the future projects that I'll be on here, I'll show you how to build dashboards with the data that is on the database. But for this project, this should be the last video. Then we shall see the next project. Also, I post videos every Friday evening when I'm not posting about projects, just something to do with data science or data engineering every week. So please subscribe. But when I'm showing you a project I worked on, it is like kind of daily for a week. This one has taken us 1 week and 1 day, but it is always like 5 days me showing you stuff that I worked on. So new tab. Let me deactivate that conda. Then I'm going to export Python path. Should be pwd. Then I'm going to export Airflow home. If you are confused about this stuff, just follow the whole project. It's a playlist on the channel, and you will learn about all these Airflow things. So pwd/Airflow. Then enter. We're also going to open another tab and do the same. Conda deactivate. Please, conda deactivate has nothing to do with the project. It's just me who set up my system in a weird way. But the rest, Python path and Airflow home, has something to do with the project. So just do it. Then let's activate the virtual environment. Then let's run Airflow scheduler. I don't remember the user, but it's fine. Let's run Airflow web server. Yeah, it's running here. Let me get this link. Yo, too much errors. They're not errors, they're warnings. And according to this project, I told you that warnings are only important when they become errors. So let me open Airflow. I think I put the user as Dalmas, and then the password was Dalmas password, I hope. Dalmas password, enter. Oops, something happened. What happened? There's an error with Airflow. Oops, something bad happened. Airflow is used by many users. It's likely that other has some. I don't want to jump into debugging a lot of things, but let me remove this. It could be a problem with the Airflow 3.10. Not Airflow 3.10, I mean Python 3.10.0, because this Python version is not used. Airflow has not been tested on this Python version, but it worked before on this project. I'm just wondering why it is failing to work now. Let me look at the scheduler. What's the scheduler saying? Is it having... This is... The scheduler seems to be running. I'm trying to read this trace back, but let me end this. Airflow web server. Oh, let's activate the environment. We're just running it. So source vm being activate, then Airflow web server, then think the scheduler does not appear to be running. Let me stop both of them. So the problem was from I had not activated my virtual environment. Let me stop both of them, then stop the scheduler, run scheduler, then run web server, then come here, okay. So there are so many tasks that are running here, and most of them are successful. So let's look at the database and we see if that data exists. So we're going to schemas, then which schema? API data. So let's just do this. Select all from... It's sending me messages. Select all from API data dot... Oh, let me refresh this. So API data, the table, dot fuel. It doesn't have a lot of data, so I'm not going to limit. Run this. Has nothing. What about weather? run. Nothing has been posted. Okay. Am I sure that I'm running it? Let's look at these tasks. Oh, we have tasks for fetching Kenya Fuel or fetching the data, but we don't have tasks for posting the data. So let's create them. We are going to Airflow, DAGs, hourly. Then I have those tasks here. And I'm going to explain them. I thought the video had ended, but there are other things. So we're going to script. The tasks for scraping the data are here. I'm going to explain them, don't worry. So up to the previous video, we ended with fetch data, fetch Ugandan, fetch Kenyan, and so forth. So today we are looking at scraping. So this is a task for scraping data. It's a Python task. This is inside Apache Airflow. If your purpose for this video, what you wanted to learn was building the API with fastapi, we are done. Now we are just looking at how the data will go into the API using Apache Airflow. So here we are inside the DAGs. Remember we created the hourly DAG. So the first task after scraping, after getting the data from the data goes into the temp folder here, and then after getting it, we scrape the data. So we create a task here that says run scrape data, and then this is the link to where the file is. Remember we already created this in the previous video, and this function. So we just call them in Python callable, and this is inside here. If you go to scrape and scrape fuel, it is here, and it inherits from base script, which we also created, and it is here, and base script takes the file path. That's why we have the file path here to what we are going to be scraping. Then the function scrape is the one that we defined here. So it runs, so we define the country. Oh, it's very important because this function here takes the country as an argument, but when you're calling it here as a Python callable, we don't put country here, but all those arguments inside this function are put as optional keyword arguments here. That's the important thing. So we have script Ugandan fuel, script Kenyan fuel, script Kenyan fuel is the same thing, but here is where the concept of the DAG works. So here we are defining upstream and downstream tasks using this operator here. This operator says that first run this task, then this task, then this task. If this one fails, then don't run the rest. So we also have run cleanup, which I will leave to be failing for now. You can look at that code in the GitHub repo, but let me just import it into the project. Where did I put that code? Let's follow it. Clean up. And the cleanup is from the scripts. So we have it here. Then from scripts, inside the scripts, we have cleanup.py. So cleaner.py just helps us to remove these temporary folders after we have done everything. Yeah, so let's see if things have failed. I'm going to refresh this. Seems to be missing from that bag. Let's come here and restart. I'm going to restart the scheduler, and I'm going to restart the web server. Run that. Scheduler is running. Then run this. Web server is running. Then run this. So we have an import error. Line 43, scrap fuel is not defined. So let's see line 43. They're saying this script fuel is not defined. Yep, I didn't import them. So let me just import everything. Let me just import the whole importation section so that I don't miss anything. Save, then restart again. It takes like 10 minutes to wait for the scheduler to pick the DAG, so I'm just going to restart it manually so that we don't waste 10 minutes. I'm also going to restart this so that it can listen to the scheduler when the scheduler restarts. So run this and run this. Then let's go back here and refresh. Yeah, things are now fine. Now let's look at our tasks. There's so many. Yeah, hopefully this gray will run. And when they run, we shall have data. So script Kenyan fuel has successfully run. So let's query fuel and we see. Yeah, and we have the Kenyan fuel here. So in this video series, we have seen how to use Apache Airflow to schedule tasks and jobs, and we have seen how to set up an API, though it has been quick because I feared this video was going to be too long. We have seen how to combine to scrape the data, fetch data from the web and save it in a temp folder, then scrape the data and post it to an API. We were supposed to look at how to build a dashboard using Plotly Dash, but that will be for maybe the next project. The link to the whole project is in the description. You can go and check it out and maybe improve on it. There are other things as part of the project package which I haven't shown in the video, but at least I've shown you the basic purpose of the project. You can now take it from here and build it further. Please don't forget to subscribe and share this with other people you think it will be important to, either at school or at work. And you have this data here. So In the next project, I think I'm going to be working on something fun, different. If you have any other project ideas, you can put it in the description. I read all the comments. Not you can't put it in the description. You can put it in the comments. Yep. Yeah. So put it in the comments. I read all the comments. I'll reply, see if I can work on it. Yep. So that is the end. Please subscribe again. Watch the whole video series for this project. There is a lot to learn. Until next time, take care of yourself. If you've learned something, please teach someone. And bye. We expect to have another video on Friday midnight, and it will be just the normal videos until I complete the next project. Then we shall have the daily videos for the next project. Okay, bye.